I need to start the recording right now. So that I can post it on YouTube for everyone to reference. Yeah, so we will be giving like a 20 seconds to 1 minute introduction of yourself. So the topics could include, you know, what's your name, what's your field of interest, what is your research area, so that sort of thing. I guess while we are waiting for other people, this may be something that you guys could think about. Okay, I think we can probably just go ahead and start. My name is Kasa Huang, and I would like to welcome everyone for coming to our first meeting of the RL Algorithms Implementation Study Group. So this is an opportunity for us to work on a specific algorithm, a specific RL algorithm every month, and we'll have a chance to read the literature together, implement the algorithms together, and because we're working on the same thing, the idea is that hopefully debugging or helping each other with questions in the literature will be a lot easier. I don't have to ask my researcher friend sending me an article and wait for like 2 days or so for him to catch up to speed. So that's the basic idea. And so this is an outline of today's talk. So the first 30 minutes is going to be introduction time, where we'll have everyone introduce each other, and then we'll talk about the monthly development cycle, and then we'll talk about how we use CleanRL as our common code base for the implementation, and I'll also do a little bit of demo as to how we could use it to do experiments and things like that, and how you could customize it. So I think to get us started, what we should do is probably have an introduction time. And it's interesting, I can't really see the lists of participating members here. Let me see. Okay, so why don't I just call everyone's name in the chat. So when you guys open the people, can you see the list of names alphabetically? Yeah, so I guess we could start with Ahmed Kahil. Ahmed, I'm gonna have to stop you, but I think your mic is a little problematic.
Yeah, my mic?
Maybe not. Can everyone else silence their mic, please?
Okay.
Yeah, great.
Cool. So, my name is Ahmed. What else? Yeah, so I come from Egypt. I got an undergrad degree from Purdue, mechanical engineering. But then I got really interested in a little bit CS. So I did Masters of Science in Robotics in the UK, in Bristol, and as of 5 weeks ago, I started a PhD in reinforcement learning. So I don't yet have a specific research interest. I guess my direction is more into the multi-agent deep RL, but I am pretty much open to anything. I'm still exploring, learning, and I want to get more hands-on implementation stuff. Like I've coded a bunch of things, but I'm not that great at it yet. Most of what I've done in RL has been just reading and theory and all that stuff. Like I read the Southern book, Introduction to Deep Reinforcement Learning, and just a bunch of papers. So yeah, I look forward to working with you guys. It should be fun.
That's great. Welcome. And actually, yeah, I should do an introduction of myself too. My name is Costa Huang, and I am a PhD student at Drexel University. I'm working with my advisor, Dr. Santiago Antañan, on reinforcement learning with real-time strategy games. And my research, I want to create this group so that I can do more implementations on some of the more advanced algorithms and Likewise, I look forward to work with you guys. And for the next person doing the introduction, could Ali Azada do the introduction, please? Sorry, I might have mispronounced your name. You guys have probably to forgive me.
That's fine. Firstly, I would like to apologize for the ambient noise because I'm using public transport. Sorry for that. My name is Ali Zadeh. I'm settled in Turkey. I'm doing my PhD in mechatronics at Istanbul Technical University. I've been using Oral since last year. I've implemented a bunch of codes on decision making for self-driving cars, and actually my interest is in using deep RL on self-driving cars for decision making and motion planning, and also multi-agent deep RL is of my interest.
All right, that's great. Welcome. And for next person, could we have the amateur developer doing the introduction, please?
No problem. So could you hear me?
Yes. Ali, are you done with your introduction?
Yes, there was no problem.
Okay. So any questions? That was from my side actually.
I think you're fine. So is the person amateur developer? That's what I see on my side. Could you give an introduction of yourself?
Is Costa, are you talking to us? Because your mic is off. We can't hear you.
My bad. Sorry. Could the next person, amateur developer, do an introduction, please? You probably have to speak a little louder. I'm having difficulty.
Okay.
Yeah.
Better?
Yeah, it's better now.
Okay, cool. So my name is Normal. I'm a master's student at the German University. I've been working in machine learning and optimization field, and recently I got interested in RL. And so far I've only done the theoretical stuff. So I've only learned the theoretical part of RL. And I've played around with the gym environment where I implemented hill climbing, reinforce with baseline, and played around with the card pole environment. But I would like to do more. And I saw your post on Reddit, and I thought this might be a good opportunity to jump right in.
Well, that's great. Welcome.
Thank you.
Yeah, my pleasure. Thank you for joining. And then for the next person, could Howard Huang do the introduction, please?
Hi, I'm Howard from Canada, McGill University. I've previously done my master's in RL as well, and working with linear RL, and I'm moving into more of the deep RL cost gradient stuff for my PhD. And currently I'm working in exploring hierarchical reinforcement learning and how to ways of doing that. Yeah.
That's great. Welcome. And I think your mic might be a little also problematic as well, but maybe this is something we can discuss later. Thank you for the introduction, Howard. And for the next person, could Miguel Martins do the introduction, please?
Can you hear me?
Could you raise your volume a little bit? It's
Like this,
better.
maybe?
Yeah, it's better.
Sorry, the mic of my headphones is out, so if you have some feedback, it's for me.
It's good.
So I'm Miguel. I'm doing the PhD on the University of Lisbon, and I'm doing RL in some courses but only basic stuff. And now this will be a nice opportunity to try state-of-the-art methods and to actually have some experience implementing them. Right now I did RL scheduling using RL, and now I'm doing for another course controlling a flexible robot, also using RL, so something more experimental. And now the idea is to expand on that.
That's great. And welcome. For the next person, could Roseland Dosa do an introduction, please?
Okay, can you guys hear me first?
Yes.
Just a mic check.
Yeah, it's good.
Okay, so as you said, I am Ruslan Dosa. You can just call me Dosa. So originally, I have a software development background, but since 1 year ago, I joined a machine learning program at the Kobe University in Japan. And so I was studying deep learning and mainly reinforcement learning for almost 2 years now. So learning the basics from scratch and implementing my way up through the algorithm. And now I'm currently studying hierarchical reinforcement learning with the aim of achieving a long-time semantical exploration with 4 reinforcement learning agents. And I guess the long-term goals, as many of you here might have the same, is the dream of artificial general intelligence. So really independent and autonomously learning agents. And unfortunately, I'm the only one in my lab which specializes in reinforcement learning. So I am looking forward to work with you all, exchanging ideas and such. Nice to meet you all.
Yeah, nice to meet you. Welcome. For next person, could Thomas Merva give an introduction, please?
So hello guys, my name is Tomáš Merva. You can call me Tom or Tomas, doesn't matter for me. Currently I'm finishing my master degree at Technical University. I'm specialized on robotics, and I would like to combine robotics with reinforcement learning, as I don't know if you are familiar with the work of Levin or Sergey Levin. So it's kind of my goal to come close to this level sometimes in the future. And yeah, I've started working with reinforcement learning in June, I think, and I have so far done some algorithms like reinforce, vanilla policy gradient, or PPL, and currently I'm working on self-autocritic with inside experience report to solve some robotics manipulation tasks. So,
That's great. Welcome to join. Welcome. And for the next person, could Vivek Mishra give an introduction, please?
Hi, can you hear
Yes.
my audio all right?
Yes, it's perfect.
Okay, so I'm a data scientist based out of Bangalore in India, and right now I'm trying to start a drone company and some bits. So it's a flapping wing drone company, and so right now I think some parts of my drone implementation can use reinforcement learning. So I'm here trying to learn some reinforcement learning.
That's great. Welcome. And I think we have our last person. Could Niju Nicholas give an introduction, please? I noticed you just joined the meeting. I don't think we can hear you. Maybe your mic wasn't working. Would it be okay if you give an introduction in the chat section of Google Hangouts? Okay, I guess we can wait for that. And also, guys, remember. Okay, yeah, we saw that. Hello all. Welcome, Niji. I would like to also remind everyone that a lot of people are posting their introductions in the Slack general channel. So feel free to check it out to get to know each other better. But okay, I think we'll start to move on. One thing I would like to talk about is the monthly development cycle. This basically we'll talk about what our meeting is about from today on. So monthly development cycle is basically will basically help us to implement one SOTA algorithm for every month. And then so the first week is going to be a literature week. We will announce our interested SOTA reinforcement learning algorithm on Slack for everyone to read. And when you read the article, you can take some notes. And if you want, start playing with the code, do a little implementation. And this in the future can be voted as well. For the first 3 months, what I had planned for is SCC, Software Actor Critic, and DDPG, Deep Deterministic Policy Gradient. And lastly, also there's TD3, which is Twin Delayed Deterministic Policy Gradient. The reason behind my choice was mostly because of this paper, benchmarking model-based reinforcement learning. And they essentially come to the conclusion that they ran the algorithms in a lot of games, and what I found is that SAC and TD3 are always the best baselines. So they don't necessarily perform the best, but their performances are always stable. It's always within a ballpark of a reasonable performance. So that's why I think it would be helpful if we implement those three for the first 3 months. And so at the end of the literature week, we'll have a presenter to introduce the RL algorithm in our weekly meeting. I hope Friday would work for everyone, but we can work on that later. And please keep in mind that we're all learning this RL algorithm at the same time, so feel free to ask questions and discuss. And what I'll have this structured is I'll have this Google Sheet right here that everyone can sign up for. So ideally we should have one presenter for literature week, for implementation week, and integration week as well. We could have more than one presenter, but ideally it shouldn't go over 2 because then it becomes harder to coordinate. But if we have 2 presenters, what we'll have to do is to have those 2 presenters sort of communicate with each other and then come up with a presentation. The presentation for the literature week will basically just kind of go over the paper, highlighting important concepts, that sort of thing. And then the second week in the monthly development cycle is going to be implementation week. So we will announce a list of gym environments, half of which have discrete action space and the other half have continuous action space. People can sign up for implementing one or more of those environments, but preferably one. So that's going to look something like this, where I have some environments. So in the future, this will be a more complete list, but this is just to show what that will look like. I have a bunch of continuous action space gym environments, and as well as some discrete action space environments. And then I also have a column saying the usual total time step to solve the problem, sort of to give you a feel of the level of computational resources you would have to spend to solve the problem. I'll post that link later, but it's essentially at the end of this or something. Oops, it should be here. But yeah, so and then at the end of the week, if you made your algorithm work, you should sign up on the weekly presentation over here, put your name down, and then work with the other presenter to talk about to show you source code, walk through the algorithm specific parts, and talk about the difficulty you face and how you overcame it. And then after that week, the third week is also going to be an implementation week. So in this week, in the third week, hopefully people will ask to make the algorithm work for discrete and continuous action space to generalize the algorithm. So you'll be asked to essentially work with at least one discrete action space gym environment and at least one continuous action space gym environments. And again, if you made the algorithm work, you're definitely welcome. If you're interested, of course, you're definitely welcome to sign up on the presenter for the implementation week. If no one signed up for a particular week, I will of course lead the conversation, but I definitely encourage anyone who can to participate and do a presentation. From my experience during the presentation, always help you to understand the subject even better because you have to explain to somebody else. And then this is the link for signing up to doing presentations in gym spaces. And then lastly, we have our integration week. So what we'll do is to benchmark these implementations. So much like this URL, what we're going to do is to create things like this for hopefully a lot of environments. Some logistics of this needs to be worked out because I personally don't have the computational resources to run everyone's experiments. But what I would hope for is I create a project and give everyone access to it so that you can submit runs to it. And in the end, so for example, for carpool, we'll be able to see the algorithm and your name so that we can compare everyone's implementation within the same chart. And then what we'll do is to evaluate them across different games and pick out the best one and integrate it to the CleanRL library. And now I want to talk a little bit about how to use CleanRL as a common code base and why I chose it. The number one reason is, I'm sorry, because I wrote it. I'm very familiar with it, but I do think it has a lot of amazing properties that I think will be very helpful for us to do implementations and do research. So if you open the link, CleanRL, it's going to look something like this. And here on the left hand of the screen, I have I just started a CleanRL Conda environments. So that's a full Anaconda environments with PiTorch installed. And what I'm going to do is to follow the command. And do this. That's basically installing the local package as, what is this? Okay, that never happened before. I think it's some sort of keychain thing, but doesn't matter. And then the repository structure looks like what you see in the screen. And then I have the CleanRL, the root folder, and the CleanRL, the actual package folder. And what I will need to do is to cd into that, and then just basically kind of run it. Oh. And it's not going to show you anything, but what you can do is you would say, and then you see this runs folder. That's basically where the TensorBoard information is going to be stored. So TensorBoard log drr runs, and then we can go to localhost 6006, and we just see the carpool is running, and then we can see the entropy loss, the policy loss, and the value loss, etc. Okay, so that's basically a start for playing with the algorithm, and now I want to introduce I want to tell you more about it, to tell you some of its crucial features. So for example, readability. This is what I think is a very helpful feature if we're doing research. So basically, every algorithm-specific logic. No. So that's because it. So what I see here is a question from Roseland, And his question was, you just started the training, but already 40K steps. That was because the program was already running when I entered this. And then the time between I started the script and the time I actually opened the TensorBoard, that's when it ran 40K time steps. So it wasn't previous run, it was a fresh run from the start. Right. Okay, let's continue. Let's talk about the readability, where so basically the first part of the code is always recording all of the hyperparameters. And then the second part is the seeding, because we want to make the research as reproducible as possible, and this is to use CUDA whenever possible. And I also leave the neural network specific implementation within the files themselves. I've seen a lot of other reinforcement learning library, they have this config files for creating neural networks, but I don't think that's really general, and in a way it's kind of confusing. So that's the design choices that I make. Then I create a policy, and then what this does is that I save the hyperparameters so that I can see in the TensorBoard. What I would do is to go here and I can see all of the hyperparameters, but also I can go into, if I choose to run the production mode and upload it to weight and biases, I can see the hyperparameters over here as well. So that's what those couple lines do. And there's something that I want to point out is that in the code, mostly I have comments like this: try not to modify. So those lines are the lines that focus on the structure of the entire script. So it should be a common structure that everyone can use. But then I also have the algorithm logic lines that are more specific to individual implementation. So try to run through the games and then deal with action space specific logics, and then eventually optimize it and record the various metrics to TensorBoard and close it in vet. And I want to point out that I also have a common file that deals with various observation space and action space. What that does is, for example, if I have a discrete observation, then I should convert it to one-hot encodings. That's a very common technique for dealing with discrete observation space. And basically all of these allow me to compute the required shape for the neural network. And as you can see in the policy, I have the output shape and the input shape and the output shape. And then the pre-process observation function is a lambda function that if I take in a discrete observation, and then I can convert it to one-hot encoding. So those are the only, so every functions here, this is the only file that has some common functions that is referenced within each of these algorithms. But most of the algorithm-specific implementation are self-contained. And now I want to talk a little bit about the hackability of CleanRL. So a lot of people, what I see, what they do is they create agent classes like DQN agent class or PBO agent class, or sometimes they write this main function. You know, if name equal to main, then execute a main function. I understand why they did it, but I don't think it's very helpful in a way. So what I usually do is I use Spider as my editor, and that gives me a lot of advantages, which one of the biggest advantages is the interactive shell. So what that means is I can just start running the script, and then I can Control-C at any time, and then I can check the variables by just using the interactive shell. I can check all of them, and basically I could do a lot of cool things like debugging on the fly. I can run for another episode. I just copy the code and run it for another episode, and done. And the other thing I can do is, for example, if there's actually recently I was trying to see if I can modify a reward array and see if it helps the policy to move towards the correct direction. And what I did is to create some sort of reward array, hard-coded. It's our reward, right? rewards. And then what I can do is to run the optimization for 100 times. So something like this. Well, I have to set the retain graph to be equal to true. But what that allows me is to see lost the backward. Retain graph equal to true. Well, one of these steps. Okay, anyway, so the point is there's a lot of things you can do because you can program on the fly, and that's something that I really enjoy working with the library that I wrote. And comparatively to something like OpenAI baselines, there's something like stable baselines which are better documented, but they're all very high leveled, and that's making it very difficult to use. So for example, they have things like this. And then what you would have to do is to set a breakpoint at this line and then step into it and step into dozens of files before you can see the algorithm part that you're really interested in. And it's just very hard if you want to do some sort of customization and experiment with it. So that's so much for the hackability, because everything is right here and then you can modify it. And if you're using an interactive shell, you can modify them on the fly. And lastly, I want to talk a little bit about experiment management. And as you can see, first of all of things is recorded by using TensorBoard. But if you want to run a lot of experiments, what we usually do is to run it in some sort of server. And I want to show you how you can do that by using this weight and biases. That'll give you this thing where you can, you can sort by the episode rewards. It gives you a lot of interesting capacities, and you get to see the hyperparameters, and then you can write this reports thing, which I use to create the benchmark. It's also an interactive benchmark because you can, click on it, check it out, and I just think it's a very useful tool. And the way as to how you would do it is to basically register an account. Well, I can leave that part to you. You can probably you guys can definitely figure out how to register an account. But if you have done so, then what you can do is to go to the setting page, and then there's this API keys. What you would do is to copy this API key. And so this is the Visual Studio code that I have running in our lab server. It's very powerful. We have like 88 cores or things like that. And what I can do is to say, there's also an example script that is posted here. But essentially you need to install weight and biases, and you need to say weight and biases log in to that. And then you can start experiments. So let me just show you an example. So if I go to here, and then what I would do is to open this benchmark. So by the way, this benchmark.sh is the file that created this interactive benchmark. So what you can do is, for example, if you're only interested in running one of them, you can cd clear and I am going to, just give it a run. Actually, let me change the name so it doesn't mess up with the benchmark. So what I will do is to press enter, and then in my home page, in my clean URL here, did it go wrong? Oh, never mind, it's here, yeah. So you can choose to visualize nothing and then view them, and then but you can also do is to add visualization line plots, and this is something really cool. I can group them by Well, when you have more than one algorithm, you can group them by the specific type of algorithm. So for example, this could be A to C, and you have another line that is PPO. But what this does is that it gives you this error bar and gives you an average of the performance of the algorithm. So yeah, anyway, in the past, this has helped me with a lot with just conducting a lot of experiments at the same time. And it has helped me to manage, and I think it's a great tool. So that's the experiment management that I want to talk about, because I think it's really important for us to record our experiments. And I want to also talk about one of the things that's really helpful is to, so for example, I think there's a very clear pathway. Do people have questions? Let me see. Do we need to use PiTorch? There's a question by Thomas Merva asking, do we need to use PiTorch, or is it completely our choice? So I would say kind of yes, because the whole idea of doing the implementation together is because we have a lot of common structures. So for example, we share the try not modify lines. That way, if your algorithm isn't working and mine is working, I can just show you the algorithm specific parts, and then you can kind of plug it in and see if it helps with your implementation. And then if you use something like Keras, I mean, if other people are willing to implement this in Keras, and you have a group of people who use Keras for your implementation, that's great. You can probably work on similar things to structure the algorithm similarly, and you can help each other to debug. But I think what would be really helpful is if everyone used PiTorch and just use the same framework and use the same sort of file structure. That way, when other people ask me to look at their code, when I ask other people to look at my code, he's going to know a lot of the stuff and help with the debugging process. And there's right. Next objective: make RL agent that can register an account. Yes, but it's basically a tool that's that records your experiments on the cloud. So, Roseland, amateur developer asked a question, could you give a more general introduction to weight and biases? I would keep it short, but essentially it's a tool that helps you to do experiment management. And then you can probably look at some of their examples by just logging on to their website. You know, although I'm kind of doing an advertisement for them, but it's just a tool for us to use to help us. But essentially attach the TensorBoard output and plug it into the cloud. And as you can see in the code base, there really isn't that much lines concerning TensorBoard, concerning weighted biases. It's just this much line, and that's it. And then I got cloud experiment management. Regarding what Roseland talked about, the framework people want to use, we can talk about that later. Okay, so that's so much for the experiment management. Right, there's the last point I want to mention is how you can make experiment. So for example, let's say I want to experiment with general advantage estimation. What I would do is to make a copy of this file and put it into the experiments folder, and look something like this, and then you can just modify the specific part of the file. So I think this implementation is actually wrong, but this is just to kind of show you how you can do this sort of modification. You create a separate file, and then you just modify the specific part. And then when you actually run this algorithm, and if you use the weight and biases, the file name is going to show up in this part of the experiment name. That way you know exactly the little change that you kind of make. And comparatively, I think it's a much clearer pathway as to how you would conduct small experiments. Let's say if you're using stable baselines and you want to, and they haven't implemented general advantage estimation. And I would imagine what you have to do is you have to make a clone of that repository and modify. You have to first of all use the breakpoints to find out where the advantages are calculated, and then you have to modify that part. And then you probably have to archive the entire repository to make it part of your experiment management. If you want to experiment with other ideas, it just gets very tedious in terms of the amount of work that you have to do small experiments. Versus if you're using just single file structure like this, it's very easy for you to do very little experiments easily. Okay, so I think that's about it as well as the demo goes. Yeah, and if you want to ask me about how to set up a Visual Studio code server sort of online so that you can access it by just using some sort of address, you can PM me and I can show you how I did it. It has helped me with a lot of the things with just running the experiments on the cloud. But that's about it. Anyone have any questions? Feel free to ask. The other thing I want to talk about, and I guess at this point, if you want, you can unmute yourself if you have any questions. So Roseland said, could I do a poll inside later to ask people what framework people want to use, TF versus PiTorch? My first reaction would be that you can definitely ask, but personally, I think it would be helpful if we just use PiTorch as the common implementation. Right. So there's a question posted by amateur developer. I'm a bit confused about how we would compare our implementation. I can talk a little bit more about that. So there, of course, isn't like a perfect way to do it. But I would imagine if we implement something like small things, especially, then this GAE continuous file would be, let's say, your implementation, and this would be my implementation. What we can compare is, for example, we can just first of all use a diff file to see what's being changed, assuming if you keep most of the structures and just modify the algorithm specific implementation. It might get more complicated if we do like a brand new implementation. Then the structure might be difficult to keep. But I think for the most part, I would know that, for example, the advantages calculations are right here versus other people's file. It might be calculated differently. And I'm hoping that people will try to keep the try not to modify files, try not to modify lines, so that we keep a lot of the common structure, and then we can help each other by just comparing the algo logic lines. So. What do you mean the results? Do you mean like how can we, like how in the integration week, how we can compare the performances of our implementation? Right, so that's the part that I haven't worked out exactly how that's going to work, but I would imagine it's going to look something like this, where instead of this, what you would see is just A2C, and then you see like A2C Costa, A2C other people, one, A2C Tom, and then by using this, we have a lot of A2C sort of running here, and we can pick out the best one. And then we can just kind of compare across different tasks and pick out the one that is the most stable and the best performing one. I think, I haven't tried it out, but I think it's achievable. So what I would do is to somehow give you access. But that's something that I'm not sure exactly how that's going to work. Yeah. Any other questions? Any comments as to what you think of the process? Any feedback as to the development cycle goes?
This is exciting.
Okay.
Yeah, I really like that we're going to be. Like, I've used stable baselines quite a bunch. For a bunch of experiments that I ran before. It's, as you say, it's very tedious. You change something small, it just takes a long time to get anything done. I've heard good things about PiTorch. So I'm willing to try that. So yeah, this whole thing. But you seem like you have a good pipeline for like running experiments and comparing things. And I like that little competitive edge to this. We'll see who has the best implementation.
Right.
Yeah. So yeah, this is all cool. Thanks.
Well, thank you for the comments. I really appreciate it. Yeah, and I think a really nice thing that could happen is, maybe by the end of next year, CleanRL would have a lot more algorithms, and what we can do is, even for your own, even it's probably directly pluggable to your own research. What you can do is to write up a very simple scripts like this one here, and then you just replace it with your gym environments. And if it doesn't work, you can just go into the files and figure out what's wrong, and then just run it. You can go check if the rewards is correct or if the Q values looks correct. It's just very directly hackable and debuggable. It should save you a lot of time for your own implementation. Yeah, some people. Let me see. Well, thank you, Peter. I'm very excited for this as well. So yeah, personally, I want to implement more reinforcement learning algorithms, but it's always challenging. So I'll share some fun stories as to why I think this would be helpful if we do this, share a lot of common structures. So one of the things that I was initially doing is to do this. For example, policy network. What I would do is to put a radian at the end of the logics, before the logics produce. And in some cases, the amount of the logics that are being produced are negative, and as a result, the values just become completely zero. And as a result, there's no way for the optimizer to know anything to optimize the gradient. So it's just a lot of things, little things like this, that it's very difficult for yourself to debug. But hopefully, if we have a common structure, I can compare, you're not using Raylo at the end of your last layer, and then we can sort of fix some bugs a lot more easily than we would have been gone through. And yeah, for example, the other thing is when I implemented the continuous domain, is that it seems the idea is you generate a mean and the standard deviation for the normal distribution. But what a lot of people what they do, originally I thought if I just generate two values and then use it for the normal distribution, it's gonna work. But it actually doesn't. It turns out what a lot of people actually do is to make the standard deviation almost basically a zero, and then it's not dependent on the state. And somehow those just little tricks like that make the algorithm learn a lot faster. And that's something that I will never be able to. Well, something would be very difficult for myself to come up with. But if we can compare other people's implementation that work, I really hope that. So for example, this is under the algorithm logic, right? We can compare this part and I know, okay, so you're initiating your standard deviation differently. Then I can know, okay, maybe this is the part that I need to tweak and see if it helps. So that's sort of the whole motivation of having a lot of people implementing using the same structure.
Yeah, that's a lot, man. It's like running the same experiment a bunch of times instead of doing it on your own. So that's really helpful. And because everyone's going to write implementation, that means they understand what's going on. So we can look at each other's codes and understand what the differences are and see what's best.
Yeah, absolutely. Yeah, like for example, when I read papers and I don't know what this symbol means, and this is because we're working on the same thing and we're reading the same literature, there's something that we should easily be able to help each other.
Yeah,
thanks. Let me see the other comments. So Howard mentioned best performance isn't necessarily good. Do we want to implement that is closest to the original in the paper or anything that works well? So that's an interesting point. So maybe we don't have to choose the best performing one. We can probably mark it as a separate one. as you said, it is true that a lot of the implementation in the paper wasn't incorporating the latest changes or things like that. Yeah, there's like a giant, there's something that I was really pissed off. So in the HBC paper, if you read the paper and you just go through pseudocode, you don't really see anything regarding the entropy. But that's actually a crucial part of the implementation because it helps with the exploration. This is also, again, something that we probably would better pick up if we are reading the same thing. But yeah, like they mentioned in a small paragraph saying, we've also found adding the entropy of the policy pi to the objective function improve the exploration by blah, blah, blah. Like, yeah, this is also something that I hope that, some people will be able to pick up, and then we can compare, and then we'll be able to directly see, oh, you're doing this entropy maximization. That's why your implementation is much better than mine, even if we're looking at the same algorithm. But I think maybe to answer your questions, I think maybe it's best if we try to implement it from the original paper, and then if there are variants, it should be noted. But yeah, we can. Yeah, I'm not really sure how, what's the correct answer to that one, but this is something definitely we can discuss during the integration week or even in implementation week.
I think I have a similar story about the FRC paper.
Really?
In the pseudocode, they don't mention any target weights, but in the implementation, you can actually see the target network.
Oh, really?
So,
even with the A2C? I thought that was a DQN specific thing.
No, the FRC paper.
Oh, really? That's also pretty interesting. Yeah, again, those are exactly the sort of things that I really want everyone to look at and talk about, because there's so many things that ourselves could be missing on. Oh, thank you, Roseland, for coming out.
I personally wouldn't put too much merit or care too much about the performances that we see in papers, because experiments are very fickle, and every paper chooses their own random 5 seats, so random, just like 5 seats experiments, yeah. So I think it would be much better to just, this definitely changed as we go on and whatever, but I think it would be much better for us to just compare against each other rather than focus on the papers, like the idea of the algorithm and implement that, and then see who has like the best performance, and then really dig deep into why that is the case. But I don't really like to compare that much against papers, because they're so vague.
Right, yeah, it is sometimes the case, yeah. That's sort of an unfortunate part. I have personally just written a paper and published to a workshop conference, and I understand to a certain extent, because sometimes you're just trying to get the experiment done, and then there isn't much time to update every details in the paper. But yeah, that's definitely frustrating as a reader. But yeah, I think you're absolutely right. What we should do is to figure out why a person's implementation is doing a lot better than our own, and we can figure out how we can improve as a general. And yeah, we should. The performance shouldn't be the only metrics as to choosing which implementation to integrate into the CleanRL library, but we should also consider other factors. For example, something like the cleanness, or how authentic is implementation, how much does it match to the paper, things like that. Yeah, great. Can I have a show of hands? I'll do this poll later in the Slack channel as well. But do most people here use PiTorch? Can you put in the chat if you use PiTorch? Can you put in the chat maybe what kind of framework that you use? Is it TensorFlow or Keras or PiTorch? I just kind of want to get a feeling of that right now.
So 50-50.
Yeah, 50-50. I'm actually surprised. Okay, so I'm sorry. So, yeah, go ahead.
Start learning PiTorch too.
I gotcha. Oh, you mean TensorFlow too?
Yes.
Right. Yeah, that's great. So that's kind of interesting. Maybe this is my part. Did I mention? So if that's the case, I would be. Yeah, I don't know. I thought maybe in the Reddit post I probably posted that this is a PiTorch. I use PiTorch. Okay, well this is sort of my input there, but it doesn't matter. So I'm not sure what's the answer to that. It also depends on whether people would like to program in PiTorch. I would like to share like a small personal story, I guess. When I started out using TensorFlow, like a lot of people, that was with TensorFlow 1.1.x, and it was just very difficult to implement. But also at the time I was starting, I spent like a month on DQN, and then when I implemented in PiTorch, it took about less than an hour. But that's not really fair because I was also learning all of the deep reinforcement learning concept with TensorFlow. But I just remember when I implemented A2C and DQN, it's so much easier with PiTorch. And one thing I want to mention is TF 2.0 looks promising, but there are still some design choices that I don't particularly enjoy. Specifically, they have like a gradient tape thing that's really ugly. You can relate to that? That's great. Yeah, like there's this TF agent library. It's probably using TF 2.0, I'm not sure. But I know there's like a someone using it. Is this TensorFlow 2.0? Yeah, it's something like that with gradient tape, and they have the loss info. This is also another reason I don't particularly like Keras, was because when you do loss in PiTorch, it's mostly just a loss equal to something. But in Keras, I think you have to model that fits. It just kind of hides away some details. And
you can also do it. You can use this to create your customized function as you show that you're using early version of TensorFlow.
I see.
For example, I do that because I can kind of organize 2 pairs and create these guys in there. Doesn't use the native feeder, so I just use Keras layers and then create my own custom functions.
I see. Yeah, I'm sure it's definitely achievable. And look at this thing. It's like gradient bars, and then you zip it, and then you do this thing. It's just and in PiTorch.
Is that actually the easy part?
That's actually the easy part, yeah. And in PiTorch, this is what it is. You're in a word clip, and all the parameters related, and that's it. But anyway, so yeah, I never. Sorry, what was that?
I can see the appeal of PiTorch.
Yeah, and I remember in TensorFlow 1.0, I don't know if this is improved in TensorFlow 2.0, but in order to get a bunch of variables to get the trainable weights, you have to do like something like with name scope. That sort of thing. That's also another pain in the butt.
I find it useful because it allows you to separate the variables.
Oh really?
I get it.
Yeah, yeah. But yeah, so I think my initial thought towards people using different framework is maybe something like if you're really interested in using a different framework, I personally would discourage it. But if you really want to do it, you might have to. I guess you could just join the conversation, but it's going to make it difficult for us to look at your code or things like that. And you probably almost have to start from scratch. And but I would say it's doable. And yes, TensorFlow 2.0, I heard about it. It apparently reserves the some of the advantages of a static graph, but it's kind of a mix. Yeah.
It's more oriented toward the production. So that's why.
Right.
I think we can mostly all agree that PiTorch is a faster or quick experiment.
Yeah, for quick experiments. And yeah, that's actually the motivation behind it, sort of, because I want to be able to do small experiments very quickly. And as you probably noticed, I don't have like runner class, which are usually required if you want to do like multiprocessing. Multiprocessing is, I'll be honest with you guys, is not really my top priority because once you throw in multiprocessing, you have to sync a lot. You have to. Maybe I was wrong, but I would imagine the code would be you have to do a lot of modular. You have to do some modularity, and as a result, the hackability and debuggability is going to be a little more difficult. So, and from my experience, the sort of script run with multiprocessing is definitely a lot faster, but in terms of the magnitude as the time you're waiting, it's not that much different, I guess. Especially if you're using like a commodity machine, if you don't have like crazy power and stuff. So I think the design choices I make here is just to keep it as simple as possible for quick experiments. Once we know what we're doing, and if you're interested in once we know what we're doing, validate an idea, then you can probably port it into stable baselines to speed up the execution 100 times or things like that. But this is I think the focus of CleanRL is to do experiments very easily.
So deep reinforcement learning has too many moving parts, so it's hard to do things. So I think it would be just best idea to use the easiest tools that we have at hand for everything that we're doing. I think that's what you're getting at.
Yeah.
I think PiTorch would be the best idea here because it's really easy to get into. And I don't even have enough experience with it, but I know it's please report TensorFlow. So.
Yeah. You guys should definitely give it a try. I personally gave TensorFlow 1.0 a try, TensorFlow 2.0 a try, and Keras a try. Oh, actually not Keras. Well, a little bit. But yeah, you guys should definitely look out different options and stuff like that. Yeah. So did anyone have a chance to do an introduction of themselves? I see there might be some other people joining during the presentation, during the meeting. Okay. So I guess what's going to happen is could one of you turn down your mic? Okay, thanks. So I think what will be helpful is either maybe not next week because it's the holiday season, but maybe either next week or the week after, I will post more detailed information about the literature week, and then we can, all of us can, if you're interested, we can start reading on the software actor critic, and then we'll also find out the time that'll work for everyone, so we can meet and discuss about the things we read in the paper, and I think that would be a good starting point.
Sounds good.
All right, that's great. So Howard says, oh, never mind, that's with the XI and ML by IR. Okay, yeah, that's great. And if you have any questions, feel free to post in the Slack channel. I also want to mention that if you have CleanRL specific questions, you can post it in this channel, and I can even. So when you post code in, let's say the reinforcement learning subreddit, in most cases people are probably not going to read your code because again, it's because they're structured differently. It's very difficult to figure out which part of the structure went wrong, or which is it structured that went wrong, or is it algorithm specifics went wrong. But if you have questions about CleanRL specifically, or if you want to debug code with CleanRL, if you customize the version, you can post it here, and me and other people will love to take a look. And I think that's about it. Anyone have something else to say? Any comments? Any questions? What was the technology you mentioned? Could you? Yeah. Could you write in the chat box? I have personally never heard of it, but I will give it a try.
You just have to write your comments in the code in a special way, and after that you just run the superscript, and no see you just output HTML documentation of the code. So classes and so on. For example, OpenCV documentation is needed.
Okay. I don't know. Right, I don't know what it is, but I would like to give it a try and evaluate it. Also everyone else is welcome to jump in to talk about it. What is it for? Is it for reproducibility?
It's more bonus for it's only documentation for a code, so it can be more than from the others. I'll send you an example, just a second.
Oh, I see what you're saying. Right. So my first reaction to it is, like what Howard mentioned. I try to keep the file looks flat, looks self-contained. So maybe generating documentation will not be that helpful because it's supposed to be the case that we don't need that much documentation and just keep a common file that deals with the action space and the observation space. But I would love to get take a look and see why would that be more helpful. De facto standard for generating documentation from edited C++ also supports other popular language. Blah blah. Online documentation, HTML, LaTeX. Oh, I see what you're saying. Maybe LaTeX would be kind of interesting and helpful. But yeah, this is something we can definitely evaluate. Any other comments or questions?
Quick questions.
Oh yeah.
Let's say last week or maybe this month, which reinforcement learning paper Mark 2.
Right. So so this is for the first 3 months. I hope that's okay with everybody. But if you strongly object to them, let me know, and I can probably make some adjustments. So I think first month will be SAC, second month will be DDPG, and the third month will be TD3. Apparently, I couldn't run into TD3 directly because I was talking to someone in the Slack channel actually, and he told me that if you don't understand the problems that DDPG is trying to solve, it doesn't make much sense to start with TD3 directly. So I think this is the starting point. Right. The other thing that I want to mention is that if you want to familiarize yourself with the code, one thing might be very helpful is to, well, first of all, just kind of run the code. Either run it as a script or run it in an interactive shell. Just kind of check out the components by clicking on it, check out the values. Like for example, this is the observation. The observation looks something like this, right? It's all discrete values, but when I plug it into the internet, it's in pre-processed. So what does that look like? So it looks something like this. Probably I was running different things, but you get the point. It's should work though. Oh, I see.
You also love features of the observation.
I see. It's because of this. It's because I need to pass it into the array. It shouldn't be just a single value. It should be an array. Right. Okay. Sorry. What was your question?
Could you also plug the features into your interactive shell?
Okay, no problem. So that's.
Well, I was just asking for the experiment later.
Yeah. I have to create something to yeah, it definitely supports it. For some editing purposes, I don't like it. That's why I use it with Visual Studio Code. So for example, with Visual Studio Code, what I can do is this is the multiply select. I can edit a bunch of things at the same time, and it's always very helpful. But yeah, so I encourage you to totally code. And the other thing that you might be interested in doing is, for example, modify the A2C code and see if you can reproduce reinforce. So what that means is it doesn't have the baselines in the advantages calculation. It also doesn't have the entropy maximization. See if you can make it work. Or the other thing you can do is to just start with the try not to modify and just delete the algorithm specific parts. So that's gonna look something like this. Algorithm logic. So if you start with almost like a template file like this, and see if you can implement A2C from scratch, and go from there, or implement any other algorithm. So it's just a nice common structure for us to have, I think, so that we can, if yours doesn't work, I can look at yours because I understand the common structure. I know where to look for bugs. So yeah, so
Also,
yeah.
although the main purpose is implementation of reinforcement learning methods, I hope we can also exchange on other ideas regarding reinforcement learning.
Yeah, of course. So I remember it was probably you or people mentioned hierarchical reinforcement learning or multi-agent. I'd love to try out those ideas. So I basically don't have anything planned after these 3 algorithms. And I think the other thing we can do is to look at OpenAI spin out and try to implement one algorithm from each of those interesting categories. So I'll be definitely open to try out different categories of inputs. It might change the structure completely, but I think that'll be something interesting that we should consider as well. Yeah, so maybe how that's going to work is people put their preferences of topics in something like this in a Google sheet, and I'll just make a poll in the Slack channel to see how many people are interested in implementing a specific algorithm. Yeah, any other questions or comments? Alright, so I think this is a great starting point, and my OBS has recorded everything. Yeah, so there's actually a bug with it I have to figure out, but that's great. So what I'll do is to find a chance to upload this to YouTube to keep track of our meeting, things like that. So if anything that's missing, we can reference it. But yeah, I think that's about it for today's meeting. I'd like to thank everyone again for attending, and I look forward to meeting you guys, to working with you guys.
Likewise.
Yeah. Alright, so I guess I'll be quitting this meeting now. If you guys have any more things to talk about, you should probably put in the Slack channel. But yeah, alright, see you guys.
Yep.
Oh wait, stop recording.
Streaky, you increase your handle to studies in general. You do snap sensitivity, so like that's right. Snap that. If you're streaky, you pick your server, you pick your streaming server that you can Twitch if you that's what you want to do with stream. Otherwise, you can just use it for recorder, save it, set up XP, and then to Twitch. So I have this to chat. Like it lays up because if you're in the voluntary group, my new drive records your company's videos and a bunch of different games and stuff to use. You can do it for uploading online, YouTube 360, other 1080. So that's if you're trying to make money off of it. Which is more of a business career, so it is. So for example, okay, sounds good. Thank you very much.